Okay, how are you, everybody? Hi, welcome our audience, and welcome everybody. Welcome all Java developers. We are here again, Java Riyadh Java user group. We welcome our guest, Italian. Hi, Italian. Thanks for accepting our invitation. Just a little bit introduction about uh, Riyadh Java user group and also our guests. So here in Riyadh Java user group, we organized all the Java related topics. We welcome any speaker and we welcome any topic that's related to the Java ecosystem. Please do subscribe to our YouTube channel and also check our previous sessions. Let's jump to our guest. Katalin is really a Java champion and is really experienced software engineer. And he is a book author. He authored two books, amazing books, JUnit in Action, and Java Persistence with Spring and Data Hibernate. And he's also a frequent speaker in all Java-related JAGs and also in online conferences as well as in persons. So we have today a very wonderful guest and also a very wonderful topic to be spoken by the guest. So before I move to the guest, welcome everybody and please do follow his account and his in Twitter. And also, if you have any questions, please drop them directly in the questions here in the question bar in the comments. And throughout the session, we will try to pick up the questions and answer them. Okay, the stage is yours, Katalin. Enjoy and good luck.
Hello, everybody. Marhaba. Thank you for the invitation. Thank you for being here. We'll have a presentation related to effective transactions management with Spring. I will tell you a few more things about myself. I'm Cătălin Tudose. I am a Java champion since the beginning of this year. For some longer time, I have a PhD in computer science, and I'm currently active as a Java and web technologies expert in Bucharest, Romania for the Luxoft company. These two books were already mentioned. I published two books with Manning. The first one, JUnit in Action, published November 2020, and Java Persistence with Spring Data and Hibernate, published January 2023. Already, both books were translated into Korean. JUnit in Action was already translated to Chinese. Maybe in the near future, there will be some translations in Arabic, depending on, on the interest and on what the publisher wants. Also, I authored 11 courses and one project at Pluralsight, mostly about Java testing, about Spring, about Java persistence, which is also in the topic of today. To quickly introduce or reintroduce you to the idea of transactions. What's a transaction? In general, is a group of operations that have what we call AC properties. Atomicity is from A, or A is from atomicity, either all actions occur or nothing occurs. It's all or nothing. Consistency. Once a transaction completed, with or without success, the data will remain in a consistent state. Isolation, I. Each transaction should be isolated from others to prevent data corruption, and will have some deeper investigation of the isolations levels during our talk. And durability, D is from durability. Once a transaction completed, its result should be durable. So this is what defines transactions, ACID. What about problems? We would like to prevent some problems in concurrent transactions, because when we run different transactions, concurrently, we may encounter problems. There may be more or less serious, and we'll examine what may happen, and then we'll see which solutions we may have in order to address at least some of them, because we'll see we may allow things to happen, or we may disallow some problems to happen. Lost update. Lost update is the most serious problem, and it should never happen, because it will mean that we have here two transactions. What we are going to use for our examples and for our demonstrations is an auction system. And what may happen? Let's say that transaction 1 will read the buy now price for some item. Let's say it is 10 whatever dollars. And meantime, transaction 2 will say, I will read this buy now price is 10. I will increase it to 12. Transaction 1 is unaware of this. It will say, what did I read? I read buy now price 10. I will increase it by 1 to 11. I will update buy now price in the database to 11. After that, transaction 2 will update the buy now price in the database to 12. So you see that we have two updates, +1 and +2, and one of the updates is lost. We saved only the update of transaction 2. The update of transaction 1 from here was lost. And this is something serious and should never ever happen, because it will destroy our logic. Okay, other problems that may occur in the context of concurrent transactions. They are less serious than the problem of lost update, and we'll see that sometimes we may allow some of them to happen. Dirty read. We have two concurrent transactions. This transaction 1 will say, okay, let's update the highest bid to 110. But I also have to see if the actioner has enough funds in order to pay. At this time, transaction 2, which is a concurrent transaction, will check the highest bid, 110. Say, oh, this is the highest bid. But transaction 1 will say, oh, you, the actioner, do not have enough funds. So I will roll back the transaction and I will revert to the previously existing highest bid, 100. So what you checked here as a highest bid, 110, was in fact a dirty read. It was not saved here because not enough funds from the actioner. This is less serious than lost update, and you'll see sometimes we may allow it to happen. Another problem is known as unrepeatable read. Again, two concurrent transactions. Transaction 1 will say, which is the highest bid, 100. Meantime, transaction 2 will say, let's update the highest bid to 110 and to commit this transaction. This first transaction will say, okay, I am unaware of what happened inside transaction 2. I read 100. I do not repeat my read. So I will say, let me bring the highest bid to 105. But when I try to say from here, the transaction will be rolled back because meantime, another transaction, this transaction 2, meantime, this another transaction 2 updated the highest bid to 110. What transaction 1 read here was unrepeatable, so the transaction 1 will roll back. Phantom reading. Again, we have two concurrent transactions. Transaction 1 will say, how many bids are there for this item? 2. Okay, 2 bids. At this time, transaction 2 will say, let me insert a new bid for the item and commit. this will impact what was on the other side of transaction 1, because now there are 3 bits for this item. So what I had previously read is a phantom reading. Something changed at the level of the whole table, not at the level of some particular row that I had previously read and updated, but at the level of the whole table, a new item appeared. So these are some problems that we may treat or we may not treat. Lost update, I said, it is the most serious problem. It should never happen. In some conditions, we may allow dirty read, unrepeatable read, and phantom reading to happen. This depends on what we call transaction isolation levels. Remember that when we said A seed, we said I is from isolation. And the levels of isolations may be smaller or larger, allowing some of these problems to happen or preventing these problems to happen. If you look at this table, you will see that here on the rows we have the isolation level, and we have here some names: read uncommitted, read committed, repeatable read, and serializable. These are names of isolation levels that are common not only to the Spring framework that we'll use for our demonstrations, but also to other frameworks that are addressing transactions. And here we have the names of the problems: lost update, dirty read, unrepeatable read, phantom reading. When we see a plus, it means that that isolation level will address that that problem. For example, read committed will prevent lost update and dirty read. Minus means that isolation level does not address that problem. So minus will mean read committed does not address unrepeatable read and phantom reading. Repeatable read does not address phantom reading. You see that always lost update is addressed. Okay, what is happening in fact when I have 2 concurrent transactions, like in our examples, in order to prevent some problems to happen? So read uncommitted will prevent only the lost update. So what will happen if my transaction number 1 is reading a row? There will be no lock. The other transaction number 2, may read or write with no restrictions. If transaction number 1 is writing, we see here on the right side, the other transaction will be prevented to write. So say I can read, but I cannot write, because if I will write at the same time, I am at the risk of having such a lost update here. This one is writing, this one is writing, so no, this should never happen. Okay, we increase the isolation level and we write here read committed. How should we understand this? Here you should read only committed data. If some data is there but uncommitted, you shouldn't read it. What is happening if transaction number 1 is reading a row? Transaction number 2 has no lock. That's why we have minus here. No lock for reading, no lock for writing. If transaction number 1 is writing, transaction number 2 is locked both for reading and for writing. Because even if we do not allow writing, if we would allow reading, it is possible that you read some uncommitted data. while we increased the isolation level to say read committed. So lock for reading. Transaction number 1 is writing. Transaction number 2 is locked both for reading and for writing. I said you will read only committed data, and let's say that this isolation read committed is usually the default isolation level in many databases. Okay, we increase the isolation level. Say isolation repeatable read. If transaction number 1 is reading, no problem to read from transaction number 2, but transaction number 2 will be locked for writing to prevent unrepeatable read. So I'm reading, please don't write because I have already read something, and if you write, maybe my reading will become unrepeatable. Of course, if transaction number 1 is writing, both reading and writing are prevented from transaction number 2. And isolation level serializable, we increase more the isolation level. If transaction number 1 is doing something on the table, the whole table will be locked for transaction number 2, both for reading and writing. So transaction number 1 working with a table will prevent any other action from some different transactions in order things of this kind like phantom reading not to happen. Don't touch my table. I am reading from it, so don't touch my table because I don't want anything to be changed at the level of the whole table. So these are the isolation levels, and it is time for us to make some demo. Let me see here. I am having some questions. What will happen is somehow we have transaction awareness built in and change the known pillars of transactions. Will that solve these problems? So as known pillars, you are changing your to solve all problems, we need to use serialization always. Okay, I see it's everything that is here is talking about the same thing. Yes, serialization is the highest isolation level. So yes, this will prevent all problems. But of course, this will impact performance. So you may ask yourself, is it really worth to increase so much the isolation level to make it the highest possible serializable to prevent anything but to impact so much the performance? I would say in most cases, if not in high majority of cases, this is not worth. Let's imagine that everyone from here is browsing the same website and would like to make reservations for a hotel or for some event. Serializable isolation level will mean that will be serialized, will be inserted in some queue, one after the other, and will have to wait for each other. So if we have 30, 40 persons, we'll have to wait for each other until our turn will come, and no one will be able to do anything if someone else is interacting with the table. So this is absolutely annoying. It is having a big lack of performance, and the customers of your website will quickly leave you. Okay, this is not feasible in real world. Performance and impact for the end user is extremely high. What if we decrease the level of isolation? That this serializable is not feasible. We allow some problems to happen. What kind of problems may happen? Let's say that several people, 2 people from here are browsing and would like to pick up the same place for an event or the same room in a hotel, and they both pick up, one of them will commit the transaction first, so it will acquire the place or the room. The other one will see his or her transaction rolled back. So, oh, meantime, your place or your room has been taken by someone else. This is really, of course, unpleasant, but not as unpleasant as the idea to wait for everyone. Okay, we don't have these situations, but you have to wait for long parts. And you impact only one single user, the one that will be rolled back. You will not impact everyone that is waiting in a long queue. So this is an example that I think it is answering the discussion that was here. So yes, it will affect the performance, and we said what we can do in order to choose some good trade-off. Okay, let's have a look at some example here with an application created using Spring Boot, and let's have a look at it. So we have this item. So what I have here is I'm having this class item. I was telling you that I am simulating some auction. It corresponds, these are persistence annotations, entities. So I said this is not just a class, it is an entity class. It corresponds to some table called items. Yes. I am having here, this is the ID that is playing the role of the primary key. And my item is having a name, a description, and the highest bid. This is the highest bid. Let's say that I have provided 100 as the highest bid. Let me start this to gain some time here. I will start this application. And I'm also having a log entity. Yes, it has an ID, some information, and some date where the log was created. And I would like to work transactionally with these items and with these logs. How do I interact with the database? I am creating this interface called item repository, saying it extends JPA repository of item and log, and also extends this item repository custom. You see that our interface has no methods, no implementations. But if I look at this JPA repository that it is extending, it says we are already provided some methods. This is an interface provided by Spring Data JPA. By simply extending this JPA of repository, this JPA repository of item and log, I am telling, hey, my repository will manage entities of type item having primary keys of type long. So you are going to inherit all these methods and more methods coming from here, for example, for CRUD repository whatsoever. You see they only have some names and there is no implementation. But there is no need to have an implementation here because Spring Data JPA is very smart and will say, aha, you are managing entities of type item having IDs of type long. It means that when I will implement this find all, because it is Spring Data JPA that will create a proxy class to implement this item repository and will implement effectively these methods. When I will implement these methods, I will know this find all will translate in a select all from item, while, for example, find by ID here will translate in select all from item, where ID equals this parameters. So it is the business of Spring Data JPA to implement this item repository and to provide the proxy class that will do everything. Plus, we are extending here item repository custom. We come with our own methods. Item repository custom is implemented here by our class item repository IMPL. And again, Spring Data JPA is very smart. It will say, okay, you are extending here this item repository customer. I see here that in this package, I have a class that implements item repository customer and has this IMPL as its ending. So I will know what to do. I will take all these methods that implement this interface, and finally your item repository will also have these methods. Okay, so we have a system built using Spring Boot, using Spring Data JPA and the persistence API, the Java Jakarta persistence API. Okay, let's have a look. We are talking about isolations. So remember here that we said we may vary the different isolation levels so that we may prevent or may not prevent some of these problems to happen. Here, I am looking at this test that you say it is transactional. Transactional is an annotation coming from Spring Framework. Yes. Spring Framework, and it may have also optionally this isolation attribute that we say here, we force it to be repeatable read. So what are we doing here? Say, give me the highest bid for item ID 0. So let's debug. I'm executing this test here. And I have inserted here this breakpoint. I will stop here, simulating a longer transaction. Okay, I'm executing this. It stopped because I have a breakpoint. So I read here the highest bid, 120. This is transaction number 1 currently in progress because I stopped it here through a breakpoint. But let's say that meantime, someone else is updating the item, saying, let's take the same item 0 and let's increase. Let's increase the highest bid with 10. Let's see what's happening while the other transaction is in progress. It read 120, and you see it is stuck here. It's stuck here because it cannot progress. Why? Because here we have repeatable read isolation level. It says, don't disturb me. This transaction will say, don't disturb me because I'm doing something. I have isolation level repeatable read, so you cannot change here. I would like to come back again, reread something, and I would like to be able to read the same thing. If I will remain here, it will be stuck forever. But let's say that our transaction number 1 is released. It says 120. You read first 120. Now you read again and you read again 120. Meantime, this other transaction was also released and it was able to increase from 120 to 130 and to commit itself. But it had originally, this update had to wait because this isolation level is repeatable read. Let's decrease the isolation level, and it will take the default of the database that is usually read committed. So this transaction is now no longer repeatable read, but it is read committed. Let's do the same thing, the same test. I started repeatable read test, which is no more repeatable read, even if the method has this name. Okay, I stopped here. I am simulating a longer transaction. Let's see if I try to update from this other side, if something different will happen. Remember, we were stuck here with this update item. Look, we are no longer stuck here. We were able to increase from 130 to 140. If I look back at this transaction, I'm still waiting here. I can release it. And see, I'm reading a new value here. My reading is no longer repeatable. I say, which is the highest bid? It was 130 and now it is 140. So I decreased the isolation level. The other transaction was able to execute and fully commit. But when I was reading here something, the same thing again, I was getting another value. Okay. Let me see if I have here something. What are some real project use cases for each of these isolation levels? When should you use each of these isolation level scenarios? Can you provide some? So in most cases, you shouldn't use serializable because it will stuck your database, as in my I haven't used it in my next demo. And in my example, when I was talking about the hotel or about the event. So serializable is too high. Read uncommitted is, on the other hand, too low in most cases. In general, you should use either read committed or repeatable read. You should pick up one of them because these are real life cases. You should, if you are happy with the situation when, like in my example, I can come back again from the same transaction and read some other value, I can allow it to be read committed. Otherwise, I should use repeatable read. If I come back again, I say, I'm reading and rereading things and I wouldn't like this to be impacted because my business logic will say, don't impact it. I should pick up repeatable read. And something else here about distributed databases, isolation. In distributed databases, we have some other patterns. So in distributed databases, there are very long transactions, and we apply some other model that maybe the saga pattern. Saga pattern will mean, for example, a real life example, I am doing something, I am transferring some money from this bank to another bank. They have no connections, these banks. And the transaction is taking a long time. And the isolation level from here, from bank number one, has nothing to do with isolation level with from bank number two. Saga pattern will mean that I may send something I was able to commit here, but I may receive some signal back saying on the other side we are not able to commit. I tried to transfer some money on the other side and the account is blocked. The money just do not vanish. I'm receiving some signal back and my transaction is rolled back here in bank one. About the default mode in Spring APA, if you are talking about isolation level, I said it's read committed. Okay, let me move to the next demonstration. Here, isolation serializable. I was saying that I have this second part of the isolation demo saying serializable. Okay, let's see what's happening. I'm trying to prevent the phantom reading here. I'm debugging. I'm setting here a breakpoint. I have five rows, yes, in my items list. And let's say that from some other side, I'm trying to add a new item. This is a longer transaction that is taking some time. This transaction is stuck because I am isolated, serializable. Don't touch my table with anything because I don't want anything to happen. I don't want a phantom reading to happen because here I'm going to reread these items and ask about the size. So if I'm releasing here, I'm still getting 5. Meantime, this one was also released and was able to commit, but it had to wait until this this transaction was committed. Let's decrease the isolation level, so no longer serializable, read committed, and I am doing the same thing. Breakpoint set here. Okay, what did I read here? I read 6. It was 5 and one more item was added. Add item. This one was stuck, remember, in my previous demonstration 2 minutes ago. Now it successfully commits, insert a new item, and you see I was having 6 and now I'm having 7 because I decreased the isolation level from serializable to the default read committed. So when I said again find all, my table was affected, impacted by this add item. Okay, let me have a look here. Yes, so most likely it is the one for read committed. My MySQL probably has repeatable read. To have courses that describe isolations using real projects deeply. How real projects, you maybe are thinking. Let me see if I can find here something. So I'm having here on Pluralsight this Hibernate Fundamentals course. Yes, that is talking about transactions and about isolation level in one of the modules. Yes, and at this time, this is what I can best advise. It was published March this year. Okay, let me go further. We still have something to talk about: propagation. Propagation is another parameter of transactions. What it is about: I am here in one bin and I am having method A that, let's say, it is transactional and it is executed within transaction 1. And I'm calling here a method B from another bin, and I'm asking myself, is this method transactional? And if it is transactional, it is executed in which transaction? The answer to these questions is provided by the propagation parameter. Okay, let's have a look at it. So we have here a table with transaction propagation. The default parameter is required. It will say I am required. So if there was no transaction in the caller method, I'm required. So I will have to start a new transaction. If there was already a transaction in the caller method, meaning here, it is required, so I can go further with it. Required, I go further with the same transaction. From what we have here, we have a description of several propagation. Besides this required, largely uses this requires new. Requires new will say there was no transaction in the caller method, let's start a transaction. There was a transaction in the caller method, suspend it and start a new transaction. It's a new, requires a new transaction. When this one T2 will be committed, you will go back to the caller method and will go further from there. Okay. Let's have a look at some example. One example from here with propagation. We are having here several examples. You will be able to find them in my GitHub repository. From several examples here, I will pick up one, which is this requires new. Let's talk about what's happening. You see that I am adding here 3 items. Okay. Let's see what's happening in this add item. this add item is a custom method here, transactional. It says add item. Some item with a name has a highest bid. And first I will log something. Let me close these things. And if I look here, I will see that this log method from this log repository IMPL has its transaction has propagation requires new. So when I am executing this test, yes, this add item executed from here, this is transactional. This will be executed on a separate transaction, requires new, yes. This one may commit separately. Then it will say, let's check the name duplicate. I don't allow you to have a duplication of the items. In case you have the duplication, I will throw this exception. This is a runtime exception, and it will stop the execution of the program, and it will roll back the transaction. Yeah. Yeah. So here I am adding 3 items. For each of the item, I am having here a log inserted before checking the name duplicate. And this is a separate transaction, as we see here. And then we force a duplication. This item repository add item, item 2, will throw a duplicate item name exception because it is duplicating this one. And we check, we assert that we have 4 logs and only 3 items. Let's run this. And explain what's happening and why we have 4 logs and only 3 items. Okay, we verified these assertions. So what happened here? Item repository add item. Here, these 3 lines. Inserted here 3 items, and separately on a separate transaction inserted 3 logs. So here we have, after executing these 3 lines, we have 3 logs and 3 items. When we execute this add item, item 2, says it will fail. It will roll back. But what will roll back? It will roll back this transaction of adding an item. This log repository is executed separately here on a different transaction because it requires new. When we end this method, this was committed. Transaction 2 was committed. We go back here. Check name duplicate. We have a duplication here. We forced the duplication to be item 2. And it will throw exception and roll back the transaction. Which transaction? This one. It has nothing to do with this transaction where the log was saved. Yes. So this transaction where we add item fails. Yes. And finally, that is why we have only 3 items but 4 logs. It is like saying, no matter if you are able to insert or not an item, save a log. The log is executed on a different transaction that commits independently. Let's force something here. And instead of saying here transactional propagation requires new, I will comment this out. I will take the default required propagation. I go back here and I would like to re-execute it. Let's see what is happening, how our test works now. It is failing. Let's see what's wrong here. Says I was expecting 4, but I was getting only 3. So this time we are having 3 items and also 3 logs. Why? Because this is executed within one single transaction. This call has transactional method says, okay, which is your propagation? If you haven't indicated it, it is the default required. If I look here into this, so say required, I was coming with transaction T1 where I was inserting the item. I will go further with the same transaction T1 where I will also do the insertion of the log. But for this add item here, I have a duplicate. I will throw an exception here, and this exception will roll back the entire transaction that is doing this. Yeah, so the entire transaction saving the item and the log is failing. The log is no longer saved, so that is why we are having only 3 logs instead of 4. Let's go back here to say propagation requires new, re-execute the test, and see what's happening. Okay, test is green again, successful. 4 logs. Okay, we are printing them using the default to string method. 4 logs and 3 items. Okay, some info here about default and unsupported isolation levels. So you should check the documentation of each database because everyone decided what they are doing. Oracle does not support repeatable. Okay, they jump directly from read committed to serializable. Okay, code is available here in my GitHub, here in transactions, together with other things, including the 2 books. And because we still have a few more minutes, I'm looking forward. Let's see. Okay, we have here. So the difference lies in the interdependence of transactions, parent-child default propagation is related to the parent transaction, and if any of the transaction fail, none of them pass all the way up. Depends here on interdependence of transactions. I think you call parent transaction here in requires new. This is what you call parent transaction. So this is the transaction where we were inserting the items. And when we are inserting the log, we are creating a separate transaction because it says here requires new. Requires new will say this transaction will be suspended, T1, and when you execute the other method, which one? This log, it will be executed on a separate transaction, independent. So this transaction is independent. If it fails, it fails independently. If it commits independently. When I come back here, yes, in add item, meaning here, this was committed independently. What will happen here in what you call parent transaction depends on this check named applicate. It may throw an exception or it may go further and commit, but independently of what happened here in the transaction in the log table. Okay. Anything else? I took the questions along the way. Anything else that? So to tell you more about, because you had questions about other works, I have, let me have a look and I will come back. One moment, let me reshare here. Other things that I may recommend. So this book, Java Persistence with Spring Data and Hibernate, I said it was published January 2023. It addresses many things related to persistence with Spring Data, with Hibernate, including, of course, transactions here, transactions and concurrency. If it addresses exactly what you are thinking about or what you need, it depends. But this chapter discusses in detail about transactions and concurrency. The online courses related to similar topics. We have here several courses about Java persistence with Hibernate 5 fundamentals, persistence in Jakarta EE10 with Hibernate, Spring Data 2022 fundamentals, Spring Data 2022 the big picture, Hibernate fundamentals. So they all talk about persistence from Java programs using different technologies, approaching several problems. If they will fit exactly what you will need depends. You may have a look at the content of the course, at the content of the book, however you would like. And of course, this GitHub of mine, the repositories are freely available. You may fork, do whatever, test, do your own work. If anything else, you may, of course, quickly find me on Twitter and on LinkedIn if you want to get in touch with me. I still have about query optimization and execution plans. I may talk to the organizer of this Java user group if we may still organize something in the near future. Anything else? Share the presentation. Yes. How can I do this? I joined the chat here. Or I should send it to the, if I press here connect, I will go to YouTube. Do we have a chat here? Or I will send it to the organizer so that he can share it with you. How is it? Share the presentation. If I send it to you, or if I join the chat here, I don't know if I join the chat I can share it here. Please tell me, because I'm connecting here. Post a comment. I can post a comment, but I don't know if I can add. Let me drag and drop. No, it doesn't allow me to drag and drop. So if I will send you the presentation, you can share it with everyone. Will that be fine? Okay. So that's
Thank
it.
you so much, Catalin, for this amazing talk. Really, we enjoyed a lot. We went through all the transactions and how to handle them. I really appreciate your time and effort, and thank you again for accepting our invitation. Thank you so much.
Thank you for your invitation, and we'll be in touch.
Okay. See you
Thank you.
guys. Thank you, audience.
Bye-bye.
Bye bye.